Sairam. Now we can discuss. Now we are discussing about fuzzy seaming clustering algorithm with solved examples. In this video, we mainly discuss about these 3 points: understanding fuzzy seaming clustering and mathematical foundation and solved examples of fuzzy seaming. Now we can discuss about. Now we can understand about fuzzy seaming clustering. What is fuzzy seaming clustering? Definition. Fuzzy seaming clustering is an advanced clustering technique that allows data point to belong to multi-clusters with different degree of membership, promoting better classification in complex datasets. The key concepts of fuzzy logic. Fuzzy logic extends traditional Boolean logic accommodating degree of truth. In clustering, it helps assign varying membership levels, enabling more manner decision-making and representing of uncertainty. Now we can see differences from k-means clustering and fuzzy clustering. Unlike k-means, where a data point is assigned to a single cluster, fuzzy c-means use a membership degree ranging from 0 to 1, reflecting the possibility of belonging to multiple clusters. In clustering, we having two types of clustering: hard cluster and soft cluster. Hard clustering assigns each data points to one distinct cluster, while soft clustering like uh, k-means, which is fuzzy clustering, allows the overlap membership, providing a more flexible and rela- realistic model of data representation. Now we can see the mathematical foundation of k-means, fuzzy clustering. Here, fuzzy clustering object function explained. The fuzzy objective function measures the optimal solution, interrupting uncertainty, providing a way to handle obscure, uh, amorphous, or impressive data in clustering analysis. Role of distance matrix. Distance matrix class qualify quanti- quantify the similarity or dissimilarity between data points. The, they influence the clustering process significantly by determining how close points are to each other. Okay. Solid examples of fuzzy seaming clusters. Here the question. Here the example. The question is you are given a following data sets of 3 points, where data sets are 1.0, 2.0, 5.0. The question is you want to apply the fuzzy seaming clustering to divide the data sets into two clusters. Here they are asking cluster 1 and C1 and C2, two clusters. Step 1. We have to write the membership matrix. Now given 3 points 1.0 and 2.0 and 5.0. Now we have to calculate the mu C1. C1. Now we have to find the mu C1 and mu C2. Here we can see that each sum of rows is equal to 1. 1.0 plus 0.8 plus 0.2 equal to 1. Now 2.0 plus 6.0 plus 0.4 equal to 1. Eh, here the mu1 mu2 will calculate the sum equal to 1, only mu1 and mu2. 0.5 plus 0.2 equal to 1. 0.6 plus 0.4 equal to 1. 0.2 plus 0.8 equal to 1. Step 2, we have to calculate the clusters C1 and C2. The formula of solving the clusters is Vj equal to sigma of where sigma sum of where I equal to 1 to n mu y muj mu ij power m into xi by sum of where sigma I equal to 1 to n mu of ij power m. Assume the cluster m equal to 2. Now we find the cluster C1 where B1 equal to 0.8, where here 0.8 equal to mu of C1. Here m equal to 2 whole square into xi means 1.0 plus 0.6 mu1 whole square into 2 plus 0.2 into 2 whole square into 5 by 0.8 whole square plus 0.6 whole square plus 0.2 whole square. So we calculate and we will solve approximately 1.50. So similarly, we have to find the cluster C2. 0.2 whole square into 1, 0.4 whole square into 2, 0.8 whole square into 5 by 0.2 whole square plus 0.4 whole square plus 0.8 whole square. The value C2 we will get approximately 4.24. We have to find the distance of use. We have to find the new clusters. The formula is 1 by sum of C of k equal to 1 to C xi minus Vj by xi minus Vk whole power 2 by m minus 1. Here for we are calculating for 1.0. Distance C1 equal to 1.50. 1.50 means cluster C1. 1.0 minus 1.50. Xi minus 1.50 C1. We'll get 0.50. Similarly V2 cluster C2 we have to find 4.24 1.0 minus 4.4. We get 3.24. Now we have to calculate the membership to cluster C1. Mu 1 comma 1 1 by 1 plus 0.5 by 3.24 whole square. Yeah, we say God, we will get the option 0. Answer 0.977. So the update membership is 0.977. We have to we have to calculate for C2 also. So the C2 is 1 minus mu1 C1. So 1 minus 0.977 will get answer 0.23. Similarly, we have to find for point 2.0 and point 0.5. Point 2 similarly 2.0 minus 1.5 equal to 0.5. 2.0 minus 4.25 we get 2.42. Similarly, we get answer of 0.95 and mu2 is 1 minus 0.95 0.047. Similarly, for point 5.0 also we get answer 0.045 and 0.955. And the last final updated membership matrix will be 1.0. For 1.0 mu1 is 0.977 and mu2 is 0.023. For 2.0 the mu1 is 0.953 and mu2 is 0.047. For 5.0 C1 is 0.045 and C2 is 0.955. And the algorithm steps are initializing the cluster center. The initialization steps involve selecting the initial cluster center, which are crucial for the convergence and effectiveness of clustering algorithms in organizing data points, updating the membership and the center. The step entails recalculating the data points membership and adjusting the cluster centers based on the last assessment. Ensure that clustering reflects the current distribution of data. Here we can explain the step by step. In this session, we'll present a data. In this session, we present a data set commonly used in fuzzy C-mean clustering includes numerical values that represent distinct features for clustering analysis. The calculation, the segment will outline the mathematical procedure involved in applying fuzzy C-mean detailed steps such as membership assignment and centroid recalculation for clarity and the final matrix. And the results are analyzing the cluster format. Here we'll explore how interpret the output clusters generated by the algorithm, discuss the significance of each cluster's characteristics and their implements. Visual representation of result. This session will focus on the graphical methods visual and the clustering results such as scatter points, which helps to understand the distribution and relationship of the data points. And this is all about the fuzzy clustering. And thank you for watching.